So what we're going to do today by way of introduction to graphing from a different form, we're going to use what's called standard form today. And what we do with this ball here is going to help us out and understand in order to provide us with these tools to graph a function by hand. This first thing it says is that we have a function that models the height of a ball. So the ball goes up, and then it comes back down, and we see it lands over here. So it says here, what is the maximum height? Well, let's see. Here's the maximum height right there. What do we call that? Starts with a V? Vertex. Okay, good. That's my vertex. Now, where does the vertex fall? What number is that? 45. That's a 45. So in other words, I have the x value that when you plug it back in here and also here, what does it give you? It's going to give you the height. So let's do that magic now. So I'm going to plug in h equals negative 0.01, but I'm going to plug in a 45 in its stead. Don't forget to square it. And I'm going to add the product of 45 and 0.9. Take a moment. So as we multiply this out, tell me, I'm going to bring down the negative and bring down the product there, 45 squared times 0.01. And then over here, I get 40.5. 0.9 times 45. And now when you do this subtraction, which is 40.5 minus 20.25, you get 20.25 feet. So what's the answer? It's up a little bit bigger than, or a little bit higher than 20 feet. And 20 feet would be the top of a two-story building. About some things, the first thing we recognize is what family does this belong to? Just like my last name is Swenson, so you know I belong to the Swensons, right? So this right here, this immediately tells me my basic shape, okay? Immediately tells me it's going to be that. Now A tells me four things in two categories. Tell me, in terms of opens, this tells me about which way it opens, right? So opens, if A is positive, it opens upward. If A is negative, it opens downward like a sad face. Next, A also tells me about its stretching slash compressing slash width slash wider, tighter, all that jazz. So if A is bigger than 1, then it's going to get tighter. And the way we say is that it stretches by that factor. Stretches by that factor, and I'm missing an H. Oh, that's right, tighter. Now, this one's a little bit harder, and when I say, let's pay attention, it's actually the absolute value of A. And then here, if A is between 0 and 1, like 1/3, 2/3, 1/5, 2/5, these kinds of things, it's a wider situation. Good. And what else? The last thing? And by the wonder of its name, we know that the vertex is H and K. HK also tells me how it shifts. It shifts left or right, up or down. In other words, where's this fancy point called the vertex? We could even go further and discuss about range. The K tells me about range, right? Whether it's a max or a min. Depending on which way A tells me it opens, that tells me if this is going to be the highest point or the lowest point, etc. All right, now standard form. Do want to point out a bunch of things with standard form, but here's the first thing that's super ultra nice. A is the same as the other one over there. Exactly the same. A tells you which way it opens. A tells you if it's going to be wider, tighter, or the same. Great. A tells me the exact same thing. Nothing new to learn. The next thing, C. C is always the y-intercept. It always tells you where it crosses the y-axis. Next thing here, and this is where it's tricky. The proof for this is a little bit ugly, so we won't show you that right now. The book does demonstrate that if I want to find the axis of symmetry, it demonstrates how this works well, but I'm going to skip over that for now. The axis of axis. All right, we fixed that. Axis of symmetry. It's a little bit ugly looking, so just go ahead and write this down. X equals negative b over 2a. There is a proof for it. We won't even show you where that comes from until we get to something called quadratic formula, because this is part of the quadratic formula. X equals negative b, blah, 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 all over to a. And by the end of January, we will be getting to that. And the last thing it tells me is I actually have to calculate the vertex. I have to plug this into the function. And that'll end up collecting, just like we did at the very, very beginning of this lesson, where we plugged the 45 in to find the height. This right here, like I said, tells me the axis of symmetry. So when you plug that puppy in, it tells you the highest or the lowest point of this quadratic. So let's see here. In this example, first we're going to find the equation of the axis of symmetry. So my answer is going to be x equals 2, x equals 15, x equals some number. Next, we want to find out what the vertex is. So I'm going to plug that into the function to here. I'm going to determine if that's a max or a min. I also, lastly, want to find out what the range is. So look here, please. Recognize that the a is the coefficient of the square term. So a is just positive 2. So how do we know where a is? We find the square, and we look for the number in front. Next, you find the x by itself. That's called the linear term. And look for the coefficient there, and that's a 4. And lastly, c is the number that's by itself, and sometimes it's 0, and so it's not written. So in this case, my c is negative 5. By the way, all this right here is just mental. You never need to make this list unless you find it helpful. Feel free to just mentalize this. Is that even a word? Mentalize it? Mentos, the fresh maker. All right, so we want to find the axis of symmetry. So we're going to use this super secret formula, the opposite of b over 2a. So remember that my b is 4. And don't forget to put that negative in the front from over there. I'm carrying that negative, or the opposite. And then the a was 2, so coincidentally it's 2 times 2 in the denominator. Now I'm going to simplify here, so I get negative 4 over 4. So x is negative 1. So the axis of symmetry is negative 1. Good. So now we know where the vertex is relative to the x. So I'm going to take that number and substitute it into the function. So this is already written out for you, so you just substitute those in. And I get y equals 2 times negative 1 squared plus 4 times negative 1 minus 5. Now we simplify. This here is 2 times 1. Beware, the double negative there is positive. Minus 4 minus 5. And my final answer is negative 7. Excuse me, my final result. So the vertex now is negative 1, negative 7. Great. So the first part, it's negative 1, is x is negative 1, my axis of symmetry. My vertex, after I substitute that in, I get out, negative 7. So there's my vertex, negative 1, negative 7. Now what? What is it? Is this going to be a max or a min? And how do we know? So now we analyze. Since my a is positive, we know that it opens up. So that means this guy here has to be a minimum.
Wait, how do you tell if it opens up?
This number right there?
If it's positive, it's up?
Yep, so it's like a smiley face. If a is positive, it's a smiley face. If a is negative, it's a sad face, like that, upside down. And in this case, the negative means the vertex is a maximum. The positive means that the vertex is a minimum. And the last thing we know is the range. And the range is completely determined by this right here. The lowest it goes, the whole function, the lowest the function goes is negative 7. So that means my y value is greater than or equal to negative 7. So the 5 things that we found the axis of symmetry, which is negative 1. Then we found the vertex by plugging that negative 1 in. We determined if it opened up, and that helped me decide if the vertex was a max or a min. And then we were able to find the range based on that minimum.